Let's do another example. Use substitution to anti-differentiate sine e to the x. So we want to let u be the inside function. Remember, we're undoing the chain rule. We let u be the inside function e to the x. Then we take the differential of u. The differential of the dependent variable u is defined to be the derivative times dx. So the derivative of e to the x is e to the x. So du is e to the x dx. I go back and I do this substitution so that all the x's become, the expressions with x become the new expressions, the different expressions, but the simpler expressions involving u. So this sine e to the x is sine u, because u is e to the x. Then what's left? E to the x dx, that sits right here. Always look down here to see this other part, what it corresponds to. This e to the x dx is just du. So my integral sine e to the x times e to the x is really just, with this substitution, integral of sine u. What do you differentiate to get sine u? Well, it's not cosine u, it's got to be what? Negative cosine u plus c. Again, this integral of sine u du is one of the ones in our list that we need to know. And we've transformed this, our original problem, into one that's in our list in section 5.4. And that's the goal of u substitution. Negative cosine e to the x plus c. That's our answer. Let's do a quick check. Derivative of cosine is negative sine. I have a composite function, so I've got the derivative of the outside, it's negative sine. The derivative of the inside is the derivative with respect to x of e to the x. Negative is a positive. And that's what I wanted.